Hi, I am Lopamudrashen. Welcome back to my channel Electronic Science Tutorial. I will start a new lecture series on NTA UGC NET and West Bengal SET exam for Electronic Science subject. Those who are not follow my channel, please follow my channel. If you like my channel, then please like, share and subscribe my channel. So let's start our class. In today's class, we discuss about the NTA UGC NET and West Bengal SET exam 2022. In this session, we cover in detail about this topic so that we can easily solve the previous year question paper of UGC NET Electronic Science. Each and every topic we can understand in easy and simple manner. So, let's begin our NTA UGC NET exam 2022 class. Okay. In today's class, we talk about the energy band diagram of an unbiased PN junction. How it looks like. This is the energy band diagram of an unbiased PN junction. This side is P-type material side and this side is N-type material side. When the junction forms, that means when the PN junction diode forms, how the energy band diagram looks like, this is the figure. This is the conduction band from P-type to N-type and this is the valence band from P-type to N-type. Okay, this is the acceptor level, this is the acceptor level and this is the donor level. What is the depletion region? How Fermi level lies? We talk about this topic. Okay. For N-type semiconductor material, the Fermi level lies near the conduction band edge EC. This is the conduction band edge for N side and it is called ECN. This is the valence band edge for N side. It is referred as EVN. This is the conduction band edge for P side. So this is referred as ECP and this is the valence band edge for P side. So this is referred as EVP. Right? So the Fermi level EF lies near the conduction band edge for N-type semiconductor and for P-type semiconductor it lies near the valence band edge EV. When a PN junction is produced under equilibrium condition, the Fermi level energy EF attains a constant value throughout the system. So how it looks like? It looks like this. This is the EF. This is the EF energy. That means Fermi level energy. Okay. Under equilibrium condition, the Fermi energy attains a constant value. It attains a constant value. Okay. It attains a constant value. And it lies near the valence band edge for P-type semiconductor and for N-type semiconductor it lies near the conduction band edge. So throughout the system Fermi level is constant. Okay. In this situation the conduction band edge ECP of the P side will be higher will be higher level than the conduction band edge of the N side, that is ECN. Similarly, the valence band edge for P side, that is EVP, also lie higher than the valence band edge EVN for the N side. So there is a difference occur, and this difference is called the energy barrier, that is EB. So what is EB? EB is represented by ECP minus ECN, because why it is ECP minus ECN? Because the conduction band edge is at higher energy level for P side, that is ECP, than the conduction band edge for N side, that is ECN. So the difference between the ECP minus ECN is called the energy barrier. Okay, and also it is equal to, this is the energy barrier for conduction band, and for valence band it is EVP minus EVN. Because the energy level of valence band in P-type material is higher than the energy band of the valence band for N-type material, and so it is EVP minus EVN. The difference between the EVP minus EVN is called the energy barrier, and this is for valence band. ECP minus ECN is the energy barrier for conduction band, and EVP minus EVN is the energy barrier for valence band. Okay, so this is the barrier energy, and this is the energy band diagram of an unbiased PN junction, right, where EF attains a constant value and it lies near the valence band edge for P-type material, and in the N-type material it lies near the conduction band edge, and the barrier energy is represented by EB, which is equal to ECP minus ECN, because the conduction band edge for P-type semiconductor is higher than the conduction band edge for N-type semiconductor. So this is the difference between the two band is called the barrier energy, and so it is ECP minus ECN representation. And the valence band energy, barrier energy, is where the EVP, that means the valence band edge for P-type semiconductor is higher than the valence band edge for N-type semiconductor. So the difference between the EVP minus EVN is called the barrier energy, which is represented by EB, and this is the energy band diagram of an unbiased PN junction. And what is depletion region, where it is creates? Here we saw the depletion region. This region is called the depletion region or space charge region. This region is called the depletion region. Okay, so this is the basic of the PN junction diode. Basic energy band diagram of an unbiased PN junction diode. Unbiased means no bias is applied externally. Okay, no bias is applied externally, and then the energy band diagram of a PN junction looks like this figure. Okay, so I think you understand this topic. Here we end today's session. Thank you. With this, we have come to the end of our session. I hope you like this video. Thank you, friends. If you like my video then please do like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.